I want to solve some trigonometric equations that require factoring. You may see some examples like this. 4 sine squared theta equals 2, 2 sine squared x minus 3 sine x plus 1 equals 0, and so on. These kinds of trig equations, they look really complicated, but they're not. They're basically just simple trig equations kind of disguised algebraically. Let's start with an example. Let's do the first one. 4 sine squared theta equals 2. Like I said, these equations require factoring, and the reason we factor is to reveal what the simpler trig equations that are hiding inside are. We have 4 sine squared theta minus 2 equals 0, and we can factor that as a difference of squares. 2 sine theta minus root 2, 2 sine theta plus root 2. And so that gives us two results. First, sine theta could equal root 2 over 2. Or, from this factor, sine theta could equal negative root 2 over 2. And each of these is just a simple sine equation. So we have to solve these two guys. Let's take a look at the unit circle. Now I'll rewrite my equations here. I've got sine theta equals root 2 over 2, sine theta equals negative root 2 over 2. Let's focus on the first one. For the sine of theta to be root 2 over 2, that means I have to find a point on the unit circle whose y-coordinate is root 2 over 2. So here, something root 2 over 2, and here. Now, when I locate these points, I remember that there are lots of points that have coordinates plus or minus root 2 over 2, and they occur at integer multiples of 45 degrees, or pi over 4. So this angle is pi over 4. And here's another one. This angle is 3 pi over 4. And again, both of these points have a y-coordinate of root 2 over 2. Remember, when you're solving a trigonometric equation, a sine equation particularly, if you find one solution, another solution can be found by taking the supplement, because the sine of two supplementary angles will always be the same. So another solution will be pi minus pi over 4, which is where we get the 3 pi over 4. So that gives us two principal solutions. And if you want to get the rest of them, you just add 2n pi, right, from periodicity. I could take pi over 4 and add 2 pi to it. That would still be a solution, because it would give me the same point on the unit circle. I could add another 2 pi, or subtract any integer multiple of 2 pi, or 3 pi over 4 plus 2n pi. Now, what about the second equation? Sine theta equals negative root 2 over 2. Well, negative root 2 over 2 would be the reflection of this point across the x-axis. X minus root 2 over 2. And so here's my angle. And it makes sense that this would be the reflection of this angle, negative pi over 4. And again, if you have one solution, negative pi over 4, another solution will be the supplement. So pi minus negative pi over 4. And of course, that's pi minus negative that's 5 pi over 4. So these are our two principal solutions. And incidentally, 5 pi over 4 is this angle, starting here, going around to there. That's 5 pi over 4. You might say, wait a second, isn't that also negative 3 pi over 4? And you can call it either one. So in our final solutions, we have to use periodicity. So we get negative pi over 4 plus 2n pi, or 5 pi over 4 plus 2n pi. So remember, when you're giving your final answer, all of these are solutions. You want to put a big or in between. All of these are possibilities. You could have pi over 4 plus 2n pi, 3 pi over 4 plus 2n pi, minus pi over 4 plus 2n pi, or 5 pi over 4 plus 2n pi.